All right, welcome back. So we got another one. This one is going to be very similar to the last one, y double prime plus ty prime plus e to the ty. So we're going to do the same game. So we're going to write e to the t equals the sum, n goes from 0 to infinity, b sub n, t to the n, where our b sub n is 1 over n factorial. Okay? Again, y is the sum, n goes from 0 to infinity, a sub n, t to the n. Oh, I should have had some initial conditions. Again, just like the last one, I definitely had to write these out before and do them. Okay, y of 0 is 0, y prime of 0 is negative 1. Okay, so that gives us, we know, a0 is 0, a sub 1 is negative 1. Okay, let me put that over here. Okay, so now let's take our y prime. You know, I wish I could do this like just from memory, but I don't. I have to redo it every time. But it's the same thing that I did last time. Okay, take the derivative, then realize, oh yeah, n equals 1 is the first non-zero term, so I'm going to have to shift everything to the right one and just sort of be a little mindful of what it is. Okay, first term is 1, so I need n plus 1, a sub 1, okay, and then t to the n, okay? Y double prime. And I just take the derivative from here, okay? So that's going to be n minus 1, n, a sub n, t to the n minus 2. Okay, again, shifting. And by the way, I wasn't good at shifting even the first 2 times that I've taught this class. This is the first time I really feel like I got that shifting down where I can do it by heart. Okay, so don't feel bad if you can't get it right away. So just remember, what is my first non-zero term? My first non-zero term, because this is 0 when n equals 1, this is 0 when n equals 0, so it's the n equals 2 term is the first non-zero term, right? So in order to shift, I'm going to remember 2 minus 1 is 1. I need that, so I'm going to have n plus 1. 2, so I'm going to need n plus 2. A sub n plus 2 t to the n. Okay. Let me highlight the terms I'm going to use. Okay. Now let's start putting it into the differential equation. Yeah, I can set up just a little bit. Okay, so I'm going to have y double prime okay, plus, now this t is going to, oh, I'm not going to use that other one, the shifted one. Oh, why did I do that? Wasted my time. Okay, so I'm going to use this one. Okay, why? Because of this t shifting everything. Okay, so I'm going to have plus sum n equals 0 to infinity n a sub n. Now normally this would be t to the n minus 1, but since I have a t, I'm just going to use t to the n. Okay, plus e to the ty. Move that down a little bit. That's e to the t. That's y. All of that equals 0. Okay, now, next thing I'm going to do, I'm going to go ahead and do that. Remember, when you multiply power series together, okay? So when you multiply the power series together, let me write it down. So n goes from 0 to infinity. K goes from 0 to n. B to the k. A to the n minus k. T to the n. Okay, I could switch it around. It could be b to the n minus k, a to the k. Either way, that's going to still give me the same thing. Okay, so putting that in, I get n goes from 0 to infinity, n plus 1, n plus 2, a sub n plus 2, t to the n, plus n goes from 0 to infinity, n a sub n, t to the n, plus sum n goes from 0 to infinity. And now I'm going to just remember that b sub k is 1 over k factorial. So 1 over k factorial, a sub n minus k, t to the n. Okay? Equals 0. All right, now let's write our recursion relation. Our recursion relation means we're going to solve for a sub n plus 2. A sub n plus 2 is 1 over n plus 1, n plus 2, and it should be negative because both of these are going to be negative when we move them to the other side. N a sub n okay, plus sum k goes from 0 to infinity, 1 over k factorial, a sub n minus k, oh, don't need t to the n anymore, equals 0. I'm just going to check that that vibes with what I did yesterday. Yep, I have it right here. Okay. All right, let's start writing out some terms. Okay, y'all are probably like waiting like, why can't we just do it on the computer? Okay, so there's a reason for that. Okay, the reason that I don't do it immediately on the computer is because my coding skills aren't perfect either. Okay, so what I'm going to do, I'm going to do the first few terms by hand, then I'm going to write the code, and then I can check. If one of them is wrong, I can sort of decide which one it is. Okay, so for example, if the first few are the same, then I'm going to be convinced that my code is right. And if I make a mistake, then I'll think what I did by hand is right, is wrong. And that actually happened with me yesterday. This term, this fifth term, I got wrong by hand. And so I had to check it because, well, everything else was working. So anyways, let's go ahead and start putting these down. So A sub 0 is 0, A sub 1 is -1. Okay, so n equals 0 is going to give us A sub 2 is -1 over, okay, 1 times 2 is 2. 0 times A0 plus this sum, for whatever reason I wrote infinity, should have been n. So that's going to be plus 1 over 0 factorial is 1. A sub 0. So A sub 0 is 0, so this is 0. Let me just check that. Yep, I had no A sub 2 term yesterday. A sub 2 term was 0, good. Okay, A sub 3. That's n equals 1. Okay, so A sub 3 is going to be -1 over n equals 1. So that's going to be 2 times 3, so 1/6. N is 1 times A sub 1 plus the sum k equals 0 to 1, 1 over k factorial, A sub n minus k. All right. -1/6. A sub 1 was -1 plus k goes from 0, so 0 is 0. K equals 0 is 0. No, that's not true. I lie. K equals 0 is going to be 1 times A sub 1. K equals 1 is going to be 1 times A sub 0. So this one's 0. Okay. So this equals A sub 1 is -1. This is going to be -1/6 times -2 is going to be 1/3. Okay. Yep, that's what I got yesterday. Okay. On that note, since I'm at the end of the page, let's go ahead and go to the Sage and see what happened, how we did it. Okay. Okay. It's actually very similar to the last one. Okay. So we still have that S term. Okay, we still have that S term, and it's basically the same term, right? So I just kept it. And the only thing I really changed was I just have now is the n times A sub n here, okay, plus S, and that's divided by n plus 1 times n plus 2, okay? So you can see here, A sub 0 was 0, A sub 1 was -1, A sub 2 was 0, A sub 3 is 1/3, A sub 4 is 1/12, and I actually did up to A sub 5 by hand in the other page, which you guys will see, but I actually had A sub 5 wrong. Since it was different here, I double checked and my code was right. Okay, so that's this one. Okay, cool. Okay. All right, let's go to one last problem. So let me stop recording and I'll see you guys in the next video.